Hello guys, welcome back to my channel. My name is Ken Carty. Now before you attempt this question, please go back to my first video on probability tree and watch it. Now let us look at this question. It says a factory has three machines, A, B, and C, producing large numbers of a certain item. Of the daily production of the items, 50% are produced on machine A, 30% on machine B, and 20% on machine C. Now what I can start doing here is simply to write down important information from this. So the probability that an item is produced on machine A, since we see it's 50%, this would give me 0.5. The probability that it is produced on machine B is 30%, which is 0.3. Now, of course, we didn't have to give it a percentage for machine C because automatically, if 50% is produced on machine A, 30% on machine B, we have 20% that would be left for machine C. So the probability that it is produced on machine C is equal to 0.2. Alright, records show that 2% of the items produced on machine A are defective. So before the items can be defective, they must be produced on that particular machine first. So we can actually say the probability that an item is defective, given that it's produced on machine A, is equal to 0.02. Alright, it says, and a corresponding 3% and 4% for machine B and C respectively, which really means that 3% is for machine B and 4% is for machine C. So we can say the probability that the item is defective, given that it's produced on machine B, is equal to 0.03, and the probability that the item is defective, given that it's produced on machine C, is equal to 0.04. Now, of course, A, B, and C are already defined, so the only thing I probably need to define here is D, because I'm using D for a defective item. All right, so you could probably put that somewhere. So D probably represents my defective item. Okay, now that we have that out of the way, there are two ways that this question can actually be worked, because we don't have to employ the use of a probability tree since it wasn't asked for, but we're going to use it in the first instance, and then we're going to show you how we can work it without using the probability tree. So let us go right ahead. Before we look at the probability of defective and so on, we have to look at the machines that are producing the items first. And our machines here, we have three machines, so I'm going to need three branches. So I'm going to have machine A, machine B, and machine C. Now the probability that an item is produced on machine A is 0.5, for machine B is 0.3, and for machine C is 0.2. Now if an item is produced on machine A, it can either be defective or not defective. And we are told that the probability that it's defective, given that it's produced on machine A, is 0.02. So I'm going to have 0.02 here. Now, of course, from the previous video, we told you that if the probability that the thing is defective is 0.02, then the probability that it's not defective would be 1 minus 0.02. So I'm going to have 0.98. Let us look at B and C. So B can also be defective or not defective. Similarly with C, so we could have defective, not defective. The probability that it's defective for machine B is 3%, which is 0.03. So I'm going to have 0.03, which means that I'm going to have not defective being 0.97. For C, the probability that it's defective is 0.04, which means that I'm going to have not defective being 0.96. Now, since I wasn't asked to draw a probability tree, I don't have to summarize the outcome and the details. I just need to pay attention to what the question is asking me for. Now, question A is saying, show that the probability that the item selected is defective is 0.027. So the only thing I'm interested in is whether or not the item is defective. So let us look at that specifically. So the item could be produced on machine A and it is defective. So I'm interested in A and defective. It could be produced on machine B and B defective. So I'm looking at B, and defective. And it could be produced on machine C and defective. So I'm looking at C and defective. Let's scroll down to get some more space. So let me write my statement here. So it's saying the probability of defective would be equal to the probability of A and defective plus the probability of B and defective plus the probability of C and defective. Now, based on what I have summarized here, you realize that we could have cut out the probability tree totally, because this is saying the probability of B being defective is the probability of A and defective plus the probability of B and defective plus the probability of C and defective. And if you want, we could refine this formula some more to avoid using the probability tree. So we could really say that this becomes the probability of A times the probability that it is defective given that it is produced on machine A plus the probability that it is produced on machine B times the probability that it is defective given that it's produced on machine B plus the probability that it's produced on machine C times the probability that it is defective given that it is produced on machine C. And we had written out all of this information in the initial stages. So all I need to do now is simply just populate the formula. So the probability that it was produced on machine A would be 0.5. The probability that is defective given machine A is 0.02. And we just keep going. Similar concept for B. So we have 0.3 times 0.03 plus 0.2 times 0.04. Now when I plug all of this inside of my calculator, I get 0.027. And since it was a proof question, I could actually say QED, that which has been proven. Part B of the question says, given that the item is defective, find the probability that it was produced on machine A. The first thing we need to do is to convert that to its symbolic representation. So let me go down here so I can get some space. So the question is asking me, what's the probability that it is produced on machine A given that it is defective? Now from my previous video on conditional probability, you'll have seen the formula for this. So it's the probability of machine A and defective over the probability that it is defective. We would have found the probability of defective already. Now machine A and defective, looking at the tree, and we also would have found this already, but look at the tree. The probability of A and defective would be 0.5 times 0.02. We found the probability of defective just now to be 0.027. So all of this goes over 0.027. So this breaks down to give me 0.370, and this is to 3 decimal places. Good. So we actually rounded this off.